Good day everyone, my name is Rika Jane Rafales Kilnet, a third year BEd student of Nursu Shatun campus, and today I'll be discussing about plane geometry. So what is plane geometry? This is a branch of mathematics that studies shapes, figures, and relationships in a flat and two-dimensional space or plane. It deals with points, lines, angles, polygons, and circles lying on a plane surface. It focuses on measurement, properties, and relationships between these geometric figures. And we have two key concepts of plane geometry. First is two-dimensional space, which has only length and width without thickness. Second is geometric relationships. This is how figures connect or relate to each other. For example, designing a garden layout or floor plan involves plane geometry since the designs are in a flat surface. What do you think is the importance of plane geometry? So the importance of plane geometry is it helps in problem solving. So it helps in visualizing shapes, areas, and distances. Another is it helps in mathematical foundation, which is essential for higher geometry, trigonometry, and calculus. We can use plane geometry in everyday applications such as in architecture and interior design with their floor plans and layouts, while in engineering with their blueprints and construction. Another is art and design with their symmetry and patterns. Lastly, mapping and navigation with the roads and plots of land. For example, architects use plane geometry to calculate dimensions and create accurate floor plans, while artists use geometric figures or shapes to create balance and symmetry in designs. Now, let us proceed to Unit 2, Basic Geometric Figures. It involves point, line, and plane. So when we say point, this is a location in space with no length, width, or thickness. A dot labeled with a capital letter. For example, point A on a graph represents a specific location. And now, what do you think is line? So this is a straight path that extends infinitely in both directions with no thickness. It is line AB with arrows at both ends. For example, the edge of a ruler can be thought of as a part of a line. And lastly, we have plane. It is a flat surface that extends infinitely in all directions. It is a parallelogram-like shape labeled with capital letters. For example, a tabletop or piece of paper represents a plane in real life. Now, we have also line segments and rays. So, line segments, it is a part of a line with two endpoints having fixed length. Example, segment AB is the straight path connecting points A and B. For real-life example, the side of a book or a table edge. And also, we have a ray. This is a part of a line that has one endpoint and extends infinitely in one direction. For example, ray CD starts at point C and extends through point D indefinitely. And for real-life example, sun rays or a flashlight beam. Now, let us proceed to Unit 3, talks about angles. So what is angle? This is a form when two rays share a common endpoint, or we call that vertex. And vertex, this is the common endpoint where the rays meet. And also, angle has arms or sides. This is the two rays forming the angle. For example, the corner of a book forms a right angle. And there are four types of angles. First is the acute angle. This is less than 90 degrees. Right angle is exactly 90 degrees. And obtuse angle, this is greater than 90 degrees but less than 180 degrees. And lastly, straight angle, which is exactly 180 degrees. And also, we'll talk about angle relationships. So first, we have complementary angles. This is two angles whose sum is 90 degrees. For example, 30 degrees plus 60 degrees is equal to 90 degrees. And also, we have another type of angle relationships, which is supplementary angles. Two angles whose sum is 180 degrees. For example, 110 degrees plus 70 is equal to 180 degrees. We are done with angles, and let us proceed to Unit 4, polygons. So what do you mean by polygon? This is a closed two-dimensional figure made of straight line segments, and each segment is called a side, and the points where sides meet are vertices. For example, a triangle, a square, a pentagon, and hexagon. And there are types of polygons. First is regular polygon. This is the all sides and angles are equal. For example, equilateral triangle and a square. Another is irregular polygon. Sides and or angles are not equal. For example, scalene triangle and rectangle. Now, let us proceed to triangles under classification. A triangle is a polygon with 3 sides, 3 angles, and 3 vertices. The sum of the interior angles of a triangle is always 180 degrees. Triangles are the simplest and most basic polygons and are commonly used in structures because of their strength. For example is a road sign shaped like a warning sign is usually a triangular. Now let us proceed to classification of triangles according to sides. First is equilateral triangle. It has 3 equal sides and 3 equal angles, and it has each 60 degrees. For example, a triangle with all sides measuring 5 centimeters. And the second is isosceles triangle. It has 2 equal sides and 2 equal angles. For example, a triangle with all sides 6 centimeters, 6 centimeters, and 4 centimeters. And lastly, the scalene triangle. It has 3 unequal sides and 3 unequal angles. For example, a triangle with sides 3 centimeters, 4 centimeters, and 5 centimeters. Let us proceed to classification of triangles according to angles. First is we have acute triangle. All angles are less than 90 degrees. For example, triangle with angles with 50 degrees, 60 degrees, and 70 degrees. And also we have right triangle. It has right angle with 90 degrees. For example, triangle with angles 90 degrees, 30 degrees, and 60 degrees. Third is the obtuse triangle. It has one obtuse angle greater than 90 degrees. For example, triangle with angles 120 degrees, 30 degrees, and 30 degrees. Let us proceed to quadrilaterals under properties. A quadrilateral is a polygon with 4 sides, 4 angles, and 4 vertices. The sum of the interior angles of a quadrilateral is 360 degrees. Quadrilaterals are commonly found in everyday objects and structures. For example, windows, books, doors, and picture frames are usually quadrilateral in shape. There are types of quadrilaterals under properties. First, we have square. It has 4 equal sides and 4 right angles. It also have all sides are parallel in pairs. Example, a chessboard square. Second is rectangle. It has opposite sides equal and 4 right angles. It has opposite sides are parallel. For example, a door or notebook. Third is parallelogram. It has 2 pairs of opposite sides equal and parallel. Opposite angles are equal. For example, slanted floor tiles. We also have rhombus. It has 4 equal sides but angles are not necessarily right angles. Opposite sides are parallel. For example, diamond-shaped signs. And lastly, we have trapezoid or trapezium. It has 1 pair of parallel sides. The non-parallel sides are called legs. For example, a table with 1 pair of parallel sides. And now let us proceed to the last unit, Unit 5, Measurement of Plane Figures. So, what is perimeter? This is the total length around a closed figure. Formula examples are, for square, perimeter is equal to 4 times side. For rectangle, perimeter is equal to 2 times length plus width. For triangle, perimeter is equal to sum of all sides. For example, if a square with side 5 centimeters, then the perimeter is equal to 4 times 5 is equal to 20 centimeters. And we have area of plane figures. Figures like triangle, rectangle, and square. So the formula of triangle is area is equal to 1/2 times base times height. For example, if the base is 6 centimeters, height is 4 centimeters, then the answer is area is equal to 1/2 times 6 times 4 is equal to 12 centimeters squared. And now we have rectangle. Area is equal to length times width. For example, if the length is 5 centimeters, width is 3 centimeters, then we have area is equal to 5 times 3 equals 15 centimeters squared. And lastly, we have square. So the formula of square is area is equal to side squared. So if you have side which is 4 centimeters, then the answer is area is equal to 4 squared. The answer is 16 centimeters squared. The 5 units of plane geometry provide a comprehensive foundation for understanding two-dimensional shapes and their properties. Beginning with the basic concepts of plane geometry, learners are introduced to the importance of real-life applications of geometric ideas. The study of points, lines, planes, angles, and polygons builds essential knowledge about how shapes are formed and related to one another. Through the classification of angles, triangles, and quadrilaterals, students develop the ability to identify and compare geometric figures accurately. And finally, the measurement of plane figures through perimeter and area equips learners with practical skills for solving everyday problems. Altogether, these units strengthen logical reasoning, spatial awareness, and mathematical problem-solving skills that is essential for further studies in mathematics and real-life applications. That would be all for today, and thank you so much for watching.